Hello, my name is Dimitrova, and I'm a senior at the University of Washington. My research project is called Locating Red Supergiants in the Galaxy NGC 6822. My mentors and collaborators for this project are Catherine Nugent and Emily Levesque from the University of Washington and Philip Massey from Northern Arizona University and Lowell Observatory. The goal of our project is to determine a list of red supergiant stars in the galaxy NGC 6822. This research is complementary to our previous work in the galaxy IC10, where we classified 138 RSGs. We are identifying RSGs to compare with stellar evolution models. Proposing a new sample of RSG candidates will be used to test stellar evolutionary theory by comparing predictions to observational results. NGC 6822 is also known as Barnard's Galaxy. It is a barred irregular type of dwarf galaxy in the Sagittarius constellation and is a member of the local group. It is located about 1.6 million light-years away from us, or 0.5 megaparsecs. To locate the RSGs, we used archival near-IR photometric data taken using UCURT. This was used in combination with data from the Gaia survey, which gave us values of parallax and proper motion to assign membership. To eliminate foreground stars, we first defined a sample of blue stars using brightness criteria with UBVRI photometry from the local group galaxy survey. Most likely, the majority of these were members of the galaxy and not foreground stars. This made them good candidates for determining the average parallax and proper motion values of the galaxy. Stars were eliminated as foreground stars if their parallax values were greater than 3 sigma from the average parallax value, and their proper motion values 3 sigma greater than or less than the average proper motion values. Next, a color magnitude diagram was constructed from the J-K and K values of the remaining sample to further remove contaminants like AGB stars and yellow supergiants. To the right is the CMD showing the stellar populations after the removal of initial foreground stars. The CMD shows 4 approximate regions circled accordingly. The stars with J-K values less than 0.6 were suspected to be yellow supergiant stars. Bright AGB stars are to the right, and continuing to the right are more AGB stars with J-K greater than 1.5. Our target RSGs are in peak at around J-K equals 1. We constrained our sample by eliminating stars outside of the expected temperature and luminosity range for RSGs. Using the equation shown, we transformed the J and K color magnitudes into effective temperature and luminosity values and made adjustments for the foreground reddening and metallicity. These values were then used to create an HR diagram of all the stars. The effective temperature range for RSGs was defined to be from 3,450 to 4,300 Kelvin. Stars outside of this temperature range and with luminosities lower than that of typical RSGs were removed. We then compared our results to previously confirmed NGC 6822 content studies in order to determine the need for adjusting our initial temperature and luminosity constraints. To do this, we matched the coordinates of our candidate RSGs to the coordinates of the confirmed RSGs to determine matches. We then plotted the matching stars over our HR diagram to see where they fell on the plot in relation to our sample and its boundaries. Additionally, we matched the RSGs in our sample to an RSG content study accompanied by spectra to compare the effective temperatures of the matching stars that we calculated to the standard temperature of the star's spectral type. This was to further test our method of determining temperature values in a temperature cutoff. The HR diagram on the right shows the results of the first comparative study with our resulting RSG sample in black and the stars that matched the confirmed RSGs in green. So far, we have identified approximately 401 red supergiant candidates. These candidate stars have remained in the sample because they have been determined not to be blue star members or red foreground stars. Therefore, they are red stars in the galaxy which fall into the expected temperature and luminosity range of typical red supergiants. To the right is the HR diagram of the remaining RSG candidate population, plotted by their effective temperatures and luminosities. They are shown highlighted in red and have an average effective temperature of 4,000 Kelvin. The points in black are the remaining member stars of the galaxy that fall out of the expected temperature and luminosity range. To the left is a map of NGC 6822's central RSG population from our candidate sample, overplotted on an H-alpha image, showing the location of the stars suspected to be red supergiants within the galaxy. In conclusion, stellar evolutionary theory provides us with the expected quantity of RSG populations. Proposing our new sample of RSG candidates in NGC 6822 can be utilized as an observational test of such theory. In combination with results from other content studies done in the local group galaxies IC10, M31, M33, and the Magellanic Clouds, current stellar evolution models across a wide range of metallicities can be further tested. Our next step will be to fully remove the AGB stars by using our CMD and applying J and J-K constraints. Next, we will plot the evolutionary models by plotting evolutionary tracks based on both single and binary star evolution on our figures. Then we will compare our work to additional NGC 6822 samples and draw final conclusions on our comparative sample studies. Once we have our final RSG selection and have analyzed our findings, we will prepare our project for publication. And that ends my presentation. Thank you very much for listening.